Yeah, answer attendance. Gahana, yes. Gahana, yes. Ganavi
ಸರ್
GR.
ಸೆಕೆಂಡ್ ಬ್ಯಾಚಿಗೆ ಬರ್ತಾರೆ ಸರ್, ಗ್ರೂಪ್ ಚೇಂಜ್ ಆಗಿದೆ.
ನನಗೆ ಗೊತ್ತಿಲ್ಲಮ್ಮ, ಇಲ್ಲಂತೂ ಈ ಬ್ಯಾಚಲ್ಲಿ ಹೆಸರಿದೆ ಅಷ್ಟೇ. ಗಾನವಿ GR. She is not coming. She has not even come for single lab. Ganavi GR, correct? If I'm right. ಈಗ ಯಾರೊಬ್ರು ಆನ್ಸರ್ ಮಾಡಿದ್ರಲ್ಲ, ಅಟ್ಲೀಸ್ಟ್ ಟೆಲ್ ಮಿ ದಟ್ ಅಟ್ಲೀಸ್ಟ್. ಯಾ
ಸರ್
ಗೀತಾ ಎಲ್ ಬಿ, ಗಿರಿ ಗಂಗಾ ಪ್ರಸಾದ್.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಎಷ್ಟನೇ ಲ್ಯಾಬ್ ಅಪ್ಪ ನಿಂದು?
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಸೆಕೆಂಡ್ ಲ್ಯಾಬ್. ಗೌತಮಿ
ಸೆಕೆಂಡ್ ಲ್ಯಾಬ್ ಸರ್.
ಗೌತಮಿ ಟಿ. ಗ್ರೀಷ್ಮಾ ಟಿ ಎಸ್. ಗ್ರೀಷ್ಮಾ ಟಿ ಎಸ್. ಒಂದ್ಸತಿ ಹೇಳಕ್ಕಾಗಲ್ಲ ನೋಡ್ರಿ. HN ಪ್ರಜ್ವಲ್. HR ಪೂಜಾ.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Is this a second lab or third lab?
ಸರ್ ಥರ್ಡ್ ಲ್ಯಾಬ್.
HR ಪ್ರೀತಿ.
Present, sir.
ಹರಿಪ್ರಿಯಾ.
Present, sir.
ಹರ್ಷವರ್ಧನ್. ಹರ್ಷಿತಾ R.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
ಹೇಮಂತ MM. ಹೇಮಶ್ರೀ R.
Present, sir.
This is a second lab?
No, sir. I have attended all the labs, sir.
Okay. I think first lab you were absent, right? Hemashri R.
No, sir. I have attended, sir.
Then why I have marked absent? Okay. Hima Bindu. Hima Bindu. Jyoti G. Karthik NS. Karthik TS. Kavana N.
Present, sir.
Kaveshri BM.
ಪ್ರೆಸೆಂಟ್ ಸರ್.
Kaveshri CS.
Yes, sir.
Kirtana S.
Present, sir.
Kirti Prasad. Keval Jain. Ellen Srinidhi. Ellen Srinidhi. Right. HN Prajwal.
Yes, sir.
Can't you answer the attendance?
No, sir, there was a network issue, sir. So there was it was not working, sir. Then I came and you were taking attendance.
Okay. Okay, let me start the experiment. So put today's date, copy down the title, what you can see on the screen. Laboratory experiment number 2, relaxation oscillator. Aim of the experiment is using 741 op-amp. Design a 1 kilohertz relaxation oscillator with 50% duty cycle. Full stop. Simulate the same. Copy down this. Kindly put today's date and start copying. Okay, so listen to my explanation for about 10 minutes, 5 to 10 minutes. Okay, later we shall explain how it goes on, how the working of this relaxation oscillator is. Okay, yeah. In today's world, as I have told you in the last week, there are two types of ICs available. Okay, in today's world, as I told you in the last week, there are two types of ICs available. Okay. What are those two types? Those two types are analog ICs as well digital IC. Okay. In today's world, there are two types of ICs available. Okay. So those two types are analog ICs as well digital ICs. Okay. So digital ICs andre yadu AND gate, NOT gate, NAND gate, NOR gate, XOR gates. Why we call digital ICs is that these ICs take only input in the form of digital logic. Andre 1, 0 sala tagolutte. It will never take in the form of waveforms. Okay. So since the AND gate, NAND gate, NOT gate, NOR gate will take the input in the form of digital logic 1s and 0s, we call such type of ICs as digital ICs. Okay. So similarly, there are other type category of IC which is called as analog IC, ANALOG, analog IC. Analog analog signals are nothing but your sine wave, triangular wave, square wave, what is a piece, what is it? Sawtooth wave. Okay. So likewise, those waves, discontinuous waves are called as analog waves. Okay. If you go with digital ICs, you cannot go with analog waveform. You have to use only ones and zeros. Okay, analog ICs work agalla adralli. AND gate alli you sine wave kodakagalla input ge. Similarly, NAND gate allu sine wave input kodakagalla. Adralli ಏನು ಕೊಡಬಹುದು NAND gate ಅಲ್ಲಿ ಬರೀ input can be 1 0 1 0 1 0 ಅಷ್ಟೇ ಇರಬಹುದು. ಹಾಗಾಗಿ ಅದನ್ನ we call it as analog digital IC. Analog IC ಅಂದ್ರೆ ಏನು? The input can be a sine wave, input can be a square wave, input can be a sawtooth wave, input can be a rectangular wave, discontinuous wave, continuous signals ಕೊಡಬಹುದು ನಾನು. Since the continuous signal can be given to the input of these ICs, it is called as analog ICs. And output can also be in the form of analog waveform. Output can also be in the form of waveforms. Okay, since the input is also in the form of waveform, output can also be in the form of waveform. It is called as analog ICs. Okay, there are many digital ICs, as I told, AND gate, NAND gate, and so on and so forth. But analog ICs are usually there are only two. Usually they will be using only two. One is 555 timer, which we studied in the last class. One is 555 timer, which we studied in the last class. The main application of 555 timer is multi-vibrator. The main application of 555 timer is multi-vibrator. Multi-vibrator andre eno, the output will be 1 0 1 0 1 0 1 0 change toggle ಆಗ್ತಾನೆ ಇರುತ್ತೆ. Multi-vibrator. Multi andre ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ. Vibrator andre it will keep on vibrating from one state to another state. Okay, from which state to which state? 0 to 1, 1 to 0, 0 to it keeps on varying, which we have done in the last class by finding out T equals T on plus T off, and we had a formula T on equals 0.693 R1 into C, T off equals 0.693 R2 into C. Then we assumed the value of C, we got the value of R1 and R2, then we fixed that IC in the circuit. Okay, we have seen the waveform also, and output will be a square wave. Output will be a square wave. Same and similar output will be also in this experiment. Similar output, the similar experiment, very much similar to the first experiment. So multi-operator, there are two types of analog ICs. The first one is 555 timer, which we studied in the last class. The second is op-amp, operational amplifier. This is also an analog IC, okay, which we'll be studying in today's lab. Operational amplifier. Yak name bantu operation amplifier andre? Amplifier andre which amplifies a small signal to a strong signal, or weak signal to a strong signal. It is called as an amplifier. Operational amplifier andre, operational yak bantu andre, this amplifier can perform. This amplifier can perform addition, subtraction, differentiation, integration, so on and so forth. Lot many mathematical operation can be performed using op-amp. Hence it is called as operational amplifier. Hence it is called as operational amplifier. Okay. Now, so the question is, analog ICs are of two, 555 timer and as well 741 op-amp. 555 timer IC and as well 741 op-amp. Okay. So now use 555 timer we studied in the last class. Today we shall go with op-amp. Today we shall go with op-amp. First, before going to the experiment, I'll tell you what is an op-amp. I'll tell you what is an op-amp. Okay, look at this symbol. Look at the symbol, what you can see on the screen. Op-amp shape is like a triangular. Op-amp shape is like a triangular. And I told you in the last class, majority of the analog ICs are of 8 pin numbers. 8 pin majority of ICs. 555 timer alone, 8 pin ittu. In the similar way, op-amp will also have 8 pins. In the similar way, op-amp will also have 8 pins. 1, 2, 3, 4 on the left side, 5, 6, 7, 8 on the right side. Okay. So out of 8 pins, we will be using only 5 op-amp pins. Out of 8 pins of op-amp, we will be using only 5. Op-amp speciality ಏನಪ್ಪಾ ಅಂದ್ರೆ 2 input ಇರುತ್ತೆ op-amp ಅಲ್ಲಿ. We have 2 inputs, 2 power supplies, 1 output. I repeat again, out of 8 pins of op-amp, we use only 5 pins. What are those 5 pins? 2 input pin, 2 VCC supply pin and 1 output pin. ಯಾವುದು 2 input pin ಅಂದ್ರೆ pin number 2 and pin number 3, which you can see on the screen. Pin number 2 and pin number 3 are your input pin. Adral one input minus, one input plus. That minus is called as inverting input. Pin number 2 is called as inverting input. Pin number 3 is called as non-inverting input. Yenik inverting input andre pin number 2 ಗೆ ನಾನು ಪಾಸಿಟಿವ್ 1 ಕೊಟ್ರೆ ಔಟ್ಪುಟ್ 0 ಆಗುತ್ತೆ. ಯಾಕಂದ್ರೆ ಇನ್ವರ್ಟಿಂಗ್ ಮೈನಸ್ ಆಗುತ್ತೆ. ಪಿನ್ ನಂಬರ್ 2 ಅಲ್ಲಿ ಏನೇ ಕೊಟ್ಟರು ಔಟ್ಪುಟ್ ರಿವರ್ಸ್ ಆಗುತ್ತೆ. ನಾನು ಸೈನ್ ವೇವ್ ಅಲ್ಲಿ ಪಾಸಿಟಿವ್ ಸೈಕಲ್ ಕೊಟ್ರೆ ಔಟ್ಪುಟ್ ಅಲ್ಲಿ ನೆಗೆಟಿವ್ ಸೈಕಲ್ ಆಫ್ ಸೈನ್ ವೇವ್ ಬಂದಿರುತ್ತೆ ಬಿಕಾಸ್ ಆಫ್ ಇನ್ವರ್ಷನ್. ದಟ್ ಈಸ್ ವೈ ಪಿನ್ ನಂಬರ್ 2 is called as inverting input pin. Pin number 3 is called as non-inverting input. Non-inverting ಅಂದ್ರೆ ನಿನ್ ಸೈನ್ ವೇವ್ ಪಾಸಿಟಿವ್ ಸೈಕಲ್ ಕೊಟ್ರೆ ಔಟ್ಪುಟ್ ವಿಲ್ ಆಲ್ಸೋ ಬಿ ಎ ಪಾಸಿಟಿವ್ ಸೈಕಲ್. ಸೈನ್ ವೇವ್ ನೆಗೆಟಿವ್ ಸೈಕಲ್ ಕೊಟ್ರೆ ಔಟ್ಪುಟ್ ವಿಲ್ ಆಲ್ಸೋ ಬಿ ಎ ನೆಗೆಟಿವ್ ಸೈಕಲ್. ಸೊ ಇಲ್ಲಿ ಏನ್ ಕೊಡ್ತೀವಿ ಔಟ್ಪುಟ್ ಅದೇ ಇರುತ್ತೆ, ನಾನ್ ಇನ್ವರ್ಟಿಂಗ್, ಇನ್ವರ್ಟ್ ಆಗಲ್ಲ ಅಂತ. Pin number 3 is non-inverting, that is why it is called as plus anta. Pin number 2 is inverting and that is why it is called as minus. Okay va? Next, ಎರಡು ಇನ್ಪುಟ್ ಬಗ್ಗೆ ಅರ್ಥ ಆಯ್ತು ಈಗ ನಿಮಗೆ. ಎರಡು ಪವರ್ ಸಪ್ಲೈ ಸೇಮ್ ವೇ, ಇನ್ಪುಟ್ ಅಲ್ಲಿ ಎರಡು ಇರುತ್ತೆ, ಅದ್ರಲ್ಲಿ ಒಂದು ಮೈನಸ್ ಒಂದು ಪ್ಲಸ್. ಪವರ್ ಸಪ್ಲೈ ಅಲ್ಲೂ ಅಷ್ಟೇ. ಪಿನ್ ನಂಬರ್ 4 is minus VCC, ಅದಕ್ಕೆ ಮೈನಸ್ ಕೊಟ್ಟಿದ್ದೀನಿ ನೋಡಿ. ಪಿನ್ ನಂಬರ್ 4 ಇಂದ ಮೈನಸ್ ಹೋಗಿದೆ, ಪ್ಲಸ್ ಗ್ರೌಂಡ್ ಆಗುತ್ತೆ. ಪಿನ್ ನಂಬರ್ 7 is plus VCC. ಪಿನ್ ನಂಬರ್ 7 ಇಂದ ಪ್ಲಸ್ ಕೊಡ್ತೀವಿ, ಮೈನಸ್ ಗ್ರೌಂಡ್ ಆಗುತ್ತೆ. Okay, so pin number 6 is output pin, where we see the output waveform. I repeat again. Op-amp is an analog IC now. Op-amp stands for operational amplifier. Okay, the pin number of op-amp is 741 ashte. Pin number of op-amp is 74. Mu A andre manufacturer microchip. Okay, so 741 is a number given to the op-amp. Op-amp is an analog IC which performs amplification as well as addition, subtraction, multiplication, division, integration, differentiation, everything it can perform. Hence it is called as operational amplifier. Okay, so it is an analog IC which is having 8 pins. It is an analog IC which is having 8 pins. Out of 8 pins, for any experimental purpose, we will be using only 5 pins. What are those 5 pins? Okay, 2 input pins, 2 VCC pin and 1 output pin. 2 input pin, 2 VCC pin and 1 output pin. Why 2 input pin? There are 2 inputs in op-amp specifically. One is inverting input, pin number 2. Another one is non-inverting input, pin number 3. If you give input to the pin number 2, output will be reverse of whatever you have given in the input. Adike invert agatadu. Invert pin anta kariyadu. If you give the input to the pin number 3, the output remains the same phase. It will remain in the same positive cycle. Positive irutte, negative irutte. Therefore, it is called as non-inverting. Similarly, to power supply pin, pin number 4, pin number 7. Pin number 4 is called as minus VCC. That is why if you look at the circuit diagram, it is given to minus voltage. Maximum is 12 volts you can give. Okay, pin number 7 is plus VCC, hence it is given to plus 12 volts. And pin number 6 is your output waveform. Where you take the output waveform. Okay, so is it clear about the op-amp pin configuration?
Yes, sir.
Okay, we don't use the other pins. Pin number 1, pin number 8 and pin number 5, we don't use it here. Okay, fine. Let's go now. Okay, look at the screen now. The question is, design a relaxation oscillator. Oscillator andre eno, oscillate andre eno, ಒಂದೇ ಕಡೆ ಇರಲ್ಲ ಅಂತ, ಇಲ್ಲಿಂದ ಅಲ್ಲಿಗೆ ಜಂಪ್ ಆಗುತ್ತೆ, ಅಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಜಂಪ್ ಆಗುತ್ತೆ. That is called as oscillator. Okay, a oscillator is a circuit which produces a continuous waveform of zeros and ones. You can see this waveform, look here. Okay, this is an oscillator. The output will neither be at 0 nor will be at 1. It keeps on jumping from 1 to 0, 0 to 1, 1 to 0, 0 to 1. Okay, such type of output producing device, electronic device, is called as an oscillator. Okay, na? Okay. So oscillator ಅಂದ್ರೆ ಅರ್ಥ ಆಯ್ತು ನಿಮಗೆ. ಆಸಿಲೇಟರ್ ಅಂದ್ರೆ ಏನು? ಅದೊಂದು ಸರ್ಕ್ಯೂಟ್ ಇರುತ್ತೆ, ಆ ಸರ್ಕ್ಯೂಟ್ ಔಟ್ಪುಟ್ ಈ ತರ ಬರುತ್ತೆ, ನಿಮಗೆ ಸ್ಕ್ವೇರ್ ವೇವ್ ತರ ಔಟ್ಪುಟ್ ಬರುತ್ತೆ. ಯಾವ ಸರ್ಕ್ಯೂಟ್ ಔಟ್ಪುಟ್ ಸ್ಕ್ವೇರ್ ವೇವ್ ತರ ಬರುತ್ತೋ ದಟ್ ಈಸ್ ಕಾಲ್ಡ್ ಆಸ್ an oscillator. ಓಕೆ, ಟೈಮರು ಅದೇ ಬಂದಿತ್ತು ನಿಮಗೆ, ಅಸ್ಟೇಬಲ್ ಮಲ್ಟಿವೈಬ್ರೇಟರ್ ಅದೇ ಬಂದಿತ್ತು ನಿಮಗೆ, ಅದಕ್ಕೆ ಹೇಳಿದೆ ಎರಡು ಒಂದೇ ಔಟ್ಪುಟ್ ಬರುತ್ತೆ ಎರಡರಲ್ಲೂ, ಸೇಮ್ ಟೈಪ್ ಆಫ್ ಮೆಜರ್ಮೆಂಟ್. ಓಕೆ, ನೆಕ್ಸ್ಟ್ ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಅಂತ ಯಾಕೆ ಕರಿತೀವಿ ಇದಕ್ಕೆ ಅಂದ್ರೆ, ಇದಕ್ಕೆ ಇನ್ಪುಟ್ ಇಲ್ಲ. ಓಕೆ, ಬರೀ ಔಟ್ಪುಟ್ ಮಾತ್ರ ಬರುತ್ತೆ. ಅಸ್ಟೇಬಲ್ ಮಲ್ಟಿವೈಬ್ರೇಟರ್ ಪ್ರೀವಿಯಸ್ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ ಅಲ್ಲಿ ಇನ್ಪುಟ್ ಇರಲಿಲ್ಲ, ಗಮನಿಸಬೇಕಾಗಿತ್ತು ನೀವು. ಇನ್ಪುಟ್ ಇಲ್ಲ, ಎರಡಕ್ಕೂ ಇನ್ಪುಟ್ ಬರಲ್ಲ. ಬಟ್ ಇನ್ಪುಟ್ ಇಲ್ಲ ಔಟ್ಪುಟ್ ಹೆಂಗ್ ಚೇಂಜ್ ಆಗುತ್ತೆ ಅನ್ನೋದು ಒಂದು ಕ್ವಶನ್ ನಿಮಗೆ ಬರಬಹುದು. ಓಕೆ, ಸೊ ಈಗ ಫಸ್ಟ್ ಮತ್ತೆ ಹೇಳ್ತೀನಿ, ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಆಸಿಲೇಟರ್ ಅದನ್ನ ಡಿಸೈನ್ ಮಾಡ್ಬೇಕು ನಾವು. ಒಂದು ರಿಲ್ಯಾಕ್ಸೇಷನ್ ಆಸಿಲೇಟರ್ ಡಿಸೈನ್ ಮಾಡ್ಬೇಕು. ಯಾವ್ದು ಯೂಸ್ ಮಾಡ್ಕೊಂಡು? op-amp ಯೂಸ್ ಮಾಡ್ಕೊಂಡು, 555 ಟೈಮರ್ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಮಾಡಬಹುದು. ಬಟ್ ದ ಕ್ವಶನ್ ಇಸ್ op-amp ಕೊಟ್ಟಿರೋದ್ರಿಂದ ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಡಿಸೈನ್ ಯೂಸಿಂಗ್ op-amp. Oscillator ಅಂದ್ರೆ ಏನು? Oscillator is a circuit which produces a continuous waveform of zeros and ones. Relaxation oscillator is one where we don't have any input. We will not give any input. The output changes its state depending upon the charging and discharging of capacitor. Okay, output changes its state depending upon the charging and discharging of this capacitor. Okay, if you look at this waveform, you observe this waveform. Okay, in this waveform you can see this capacitor charging here. Capacitor charge ಆಗ್ತಾ ಹೋಗುತ್ತೆ ನೋಡಿ. This is the charging. Capacitor keeps on charging. Capacitor charge ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆದ ತಕ್ಷಣ ಔಟ್ಪುಟ್ 1 ಆಗುತ್ತೆ ನೋಡಿ, ಇಲ್ಲಿ ಔಟ್ಪುಟ್ 1 ಆಗುತ್ತೆ. Capacitor charge ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆದ ತಕ್ಷಣ ಔಟ್ಪುಟ್ 1 ಆಗುತ್ತೆ. And output remains in the 1. Okay, till capacitor completely charges. Full charge ಆಗತ್ತೆ, output 1 ಅಲ್ಲೇ ಇರುತ್ತೆ. ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಆ capacitor full charge ಆದ ತಕ್ಷಣ it starts discharging like this. Once it starts discharging, output comes to 0. Output comes from 1 to 0 and stays in 0. and stays in 0. Okay, 0 ಬಂದ್ಬಿಟ್ಟು 0 ದಲ್ಲೇ ಉಳ್ಕೊಂಡ್ಬಿಡುತ್ತೆ ಅದು. ಓಕೆ, ಎಲ್ಲಿವರೆಗೂ 0 ದಲ್ಲಿ ಉಳ್ಕೊಳ್ಳುತ್ತೆ? till the capacitor is completely discharged. ಅಂದ್ರೆ ಅರ್ಥ ಏನು? ಕೆಪಾಸಿಟರ್ ಚಾರ್ಜ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆದ್ರೆ ಔಟ್ಪುಟ್ 1 ಹೋಗುತ್ತೆ, ಕೆಪಾಸಿಟರ್ ಡಿಸ್ಚಾರ್ಜ್ ಆಗಕ್ಕೆ ಸ್ಟಾರ್ಟ್ ಆದ್ರೆ ಔಟ್ಪುಟ್ 0 ಬರುತ್ತೆ. ಅಷ್ಟೇ ಕಾನ್ಸೆಪ್ಟ್ ಇಲ್ಲಿ. when capacitor starts charging, output will go to 1. when capacitor starts discharging, output will come from 1 back to 0. This way the output will change its state depending upon the charging and discharging of capacitor. Hence there is no need of any input anta heltivi. Okay, so I repeat again, the oscillator is the electronic device which keeps on changing, which generates a square waveform which triggers from 1 to 0, 0 to 1, 1 to 0, 0 to 1. Okay, relaxation oscillator is one where we don't have input. Relaxation oscillator is one where we don't have input, but the output changes its state depends upon the charging and discharging of the capacitor. When capacitor charges to 1, starts charging, output goes to 1. When capacitor starts discharging, output comes back to 0. Output comes back to 0. Okay, so write down this. I'll show you. You write down these two lines now. Up to here you write down in your observation book. Please maintain your observation book properly with proper dates, what I have conducted the experiment, because yesterday VTO has asked the documents. So if in case if they need some proof, we may ask you to upload your observation book snapshots to the Google form. Okay, as you have done the assignments. Okay, so please be careful, maintain ಅದು ಸುಮ್ಮನೆ ಕೂತ್ಕೊಂಡ್ರೆ ಬರ್ದಾಕ್ ಬಿಡು ಅಂತ ಒಟ್ಟಿಗೆ ಬರೀಬೇಕಾಗತ್ತೆ ಆಮೇಲೆ. Okay, better to maintain properly on regular basis. Finished?
Yes, sir.
Yes, sir.
Okay, please write down. Okay, let's see now. Let's see. Okay, we got to know what is op-amp. Okay, 5-pin IC, 5-pin ಅಲ್ಲಿ ಯಾವುದು ಅಂತ ಎಲ್ಲ ಗೊತ್ತಾಯ್ತು. We got to know what is oscillator. We got to know what is relaxation. Okay, so we got a definition now. Now let us come back to the question. Okay, copy down this question. Design a relaxation oscillator for a given frequency of 1 kilohertz. ಇದನ್ನ question ಅಲ್ಲಿ ಕೊಟ್ಟಿರೋದು. Okay, so copy down this. Okay, once if you're done with that, you copy down this circuit copy ಮಾಡ್ಕೊಳ್ಳಿ. circuit and as well as this waveform. You have R1, R2 to pin number 6. R1, R2 junction point, the shorting point of R1, R2 is given to pin number 3. Okay, so pin number 2 it should go to capital R. R again, other end of R should come to pin number 6. One connection of pin number 2 should go to capacitor C. The other end of capacitor will come to ground. Pin number 4 is given to minus VCC, which is minus 12 volts. Pin number 7 is given to plus VCC, plus 12 volts. Across pin number 6, we are going to take the V0 output. Okay, once after this diagram, take up this waveform. Output voltage V0 equals T on, which is a on period, T off, which is off period. Total time T equals T on plus T off. Okay, total time period T equals T on plus T off. And the below waveform is VC. VC stands for capacitor voltage, where TC stands for charging time, TD stands for discharging time. TC stands for charging time, TD stands for discharging time. Write down that. Okay, look now how I designed this. Okay, design madadಕ್ಕೆ ಮುಂಚೆ you look at the circuit diagram. We have two things here, R2 and R1. We have two things here, R2 and R1. We have to find out the value of ಇದರಲ್ಲಿ ಏನು ಕಂಡುಹಿಡಿಯಬೇಕು ಈ ಸರ್ಕ್ಯೂಟ್ ಅಲ್ಲಿ ಅಂದ್ರೆ R1 R2 ಎಷ್ಟು ವ್ಯಾಲ್ಯೂ ಅಂತ ಕಂಡುಹಿಡಿಯಬೇಕು. Okay, also we have to find out this C. Also we have to find out this C. Also we have to find out this R. We have to find out this R. Therefore, I need to find out four things here. R1, R2, C and R. I need to find out four things here. R1, R2, C and R. Okay, na? Okay. So now the first step is to find out R1 and R2. The first step is to find out this R1 and R2. For that, the formula is take up this. For the formula is R2 equals 1.16 times of R1. It is fixed. R2 equals 1.16 times of R1. R2 equals 1.16 times of R1. Okay, so this is the fixed formula you need to use for this. R2 equals 1.16 times of R1. Okay, fine. So whatever I assume the value for R1, that into 1.16 will be the value of your R2. R1 gain assume ಮಾಡ್ತೀನೋ ಅದರದ್ದು into 1.16 will be the value of your R2. ಅರ್ಥ ಆಯ್ತಾ? ಈಗ ನಾನು ನನ್ನ ಎಕ್ಸ್ಪೆರಿಮೆಂಟ್ಗೆ I assume R1 equals 10 kilo ohm. I assume for this experiment, I assume R1 equals 10 kilo ohm. Therefore, what is my R2? ಬರ್ಕೊಳ್ಳಿ ಹಂಗೆ ಬರಿತಾ ಹೋಗಿ. We know that R2 equals 1.16 times of R1. We know that R2 equals 1.16 times of R1. Let assume R1 equals 10 kilo ohm. Let me assume R1 equals 10 kilo ohm. Therefore, what is the value of R2? 10 kilo ohm into 1.16. 10 kilo ohm into 1.16. Okay, 10 kilo ohm into 1.16 is given is equal to 11.6K. Is equal to 11.6K. Therefore, R2 equals 11.6K. (1.16 times of R2). Okay, next. Okay, fine. So we got to know the value of R1 equals 10K, R2 equals 11.6K. ಅಲ್ಲಿಗೆ ಎರಡು ಸಿಕ್ತು ನನಗೆ R1 ವ್ಯಾಲ್ಯೂ ಸಿಕ್ತಿದ್ರಲ್ಲಿ I got to know my R1 equals 10K. Okay, so then I got to know my R2 equals 11.6K. Okay, ನಾಲ್ಕರಲ್ಲಿ ಎರಡು ಮುಗೀತು ಈಗ. ಇನ್ನೆರಡು ಬೇಕು. ಯಾವುದು? We need to know this R. We need to know this R as well. We need to know this C. We need to know this C. Okay, for that the formula is F naught equals 1 by 2 RC. ಇಲ್ಲಿದೆ ನೋಡಿ. Okay, look at here. F naught equals 1 by 2 RC. Okay, F equals 1 by 2 RC is the formula. ಬರ್ಕೊಳ್ಳಿ ಇದು. Okay, F equals 1 by 2 RC. F naught ಏನು ಬೇಡ, ಬರೀ F ಬರ್ಕೊಂಡ್ರೆ ಸಾಕು. F equals 1 by 2 RC. ಓಕೆ, ಸೊ ಇದ್ರಲ್ಲಿ ಏನೇನು ಗೊತ್ತಿದೆ ನಮಗೆ? ಎಫ್ ಕ್ವಶನ್ ಅಲ್ಲೇ ಕೊಟ್ಟಿದ್ದಾನೆ. ಫಾರ್ ದ ಗಿವನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಆಫ್ 1 ಕಿಲೋವಾಟ್ಸ್ ಅಂತ ಕ್ವಶನ್ ಅಲ್ಲೇ ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾನೆ ಇದರಲ್ಲಿ. ಸೊ ಐ ನೀಡ್ ನಾಟ್ ವರಿ ಅಬೌಟ್ ಮೈ ಎಫ್ ಕ್ವಶನ್ ಅಲ್ಲೇ ಕೊಡ್ತಾರೆ. ಓಕೆ, ಸೊ ಯು ನೀಡ್ ಟು ಫೈಂಡ್ ಔಟ್ ಆರ್ ಅಂಡ್ ಸಿ. ಆರ್ ಅಂಡ್ ಸಿ ಎರಡು ಅನ್ನೋನ್ ಟರ್ಮ್ಸ್. ಟು ಅನ್ನೋನ್ ಟರ್ಮ್ಸ್ ಕೆನಾಟ್ ಬಿ ಡನ್. Hence I have to assume either of the one. ನೋಡಿ ಇಲ್ಲಿ ನೆಕ್ಸ್ಟ್ ಲೈನ್ ಬರ್ತಿದ್ದೀನಿ. ಗಿವನ್ ಫ್ರೀಕ್ವೆನ್ಸಿ ಎಫ್ ಈಕ್ವಲ್ಸ್ 1 ಕಿಲೋಹರ್ಟ್ಸ್. Given frequency f equals 1 kilohertz. Okay, assume c equals 0.1 microfarad. ಇಲ್ಲಿ RC ಎರಡು unknown terms ಇದೆ. ಅದರಲ್ಲಿ assume your c equals 0.1 microfarad. Assume c equals 0.1 microfarad. ಅವಾಗ you need to calculate your R. ಹೆಂಗೆ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತೀರಾ? R equals 1 by 2 FC ಆಗುತ್ತೆ. ಚೇಂಜ್ ಮಾಡ್ತೀರಾ, ಕ್ರಾಸ್ ಮಲ್ಟಿಪ್ಲಿಕೇಶನ್ ಮಾಡಿಬಿಟ್ಟು. f equals 1 by 2 RC ಇರೋದು R equals 1 by 2 FC ಆಗುತ್ತೆ. Therefore, 1 divided by 2 into 1 kilohertz into 0.1 microfarad. I repeat, F equals 1 by 2 RC. F is given in the question as 1 kilohertz. Okay, I don't know the value of R and C. I assume C, which is equal to 0.1 microfarad. Okay, now I need to calculate the value of R with the formula R equals 1 by 2 FC. R equals 1 by 2 FC. So therefore 1 by 2 into 1 kilohertz into 0.1 microfarad into 0.1 microfarad, which is equal to 5 kilo ohm. Therefore ultimately I got to know that the value of this R is 5 kilo ohm. Okay, the value of this C is 0.1 microfarad. Idu sikkita 1.16 times of R1 sikkitidu. So I got to know all the four values. Okay, take up this. Finished?
Yes, sir.
Okay. Now okay. So as usual, multisim. Okay. Look at very carefully. Look very carefully how I do. So zoom mark nodi. So zoom mark nodi. Okay. Since I told you this op amp is analog. Since I told you op amp is analog, go for this analog part here. Go for this analog part here. Click on left click on the analog part here. Okay. You will get lot of ICs. In that, go with the first one. Op amp annadra mele click ಮಾಡಿ. Op amp annadra mele click ಮಾಡಿ. Okay na? Click ಮಾಡಿದ್ಮೇಲೆ you can see the option here 741 ಅಂತ ಕಾಣ್ತಾ 741 ಕಾಣ್ತಾ ಇದೆಯಾ?
Yes, sir.
Okay, you can see sorry. Okay, you can see 741 here. Click on 741 and okay ಕೊಟ್ಟು ಪ್ಲೇಸ್ ಮಾಡಬೇಕು. Okay ಕೊಟ್ಟು ಪ್ಲೇಸ್ ಮಾಡಬೇಕು. ಮತ್ತೆ ಲೆಫ್ಟ್ ಕ್ಲಿಕ್ ಕೊಟ್ಟರೆ ಪ್ಲೇಸ್ ಆಗುತ್ತೆ. ಡಿಲೀಟ್ ಮಾಡ್ತೀನಿ. I repeat once again, go for this analog. Go for this analog, click on the left click on the analog. Okay, so click on the first op amp IC. ಅದರಲ್ಲಿ op amp 741 ಬರುತ್ತೆ. Okay ಕೊಟ್ರೆ that will be your IC. Okay, so ಇದು ರಿವರ್ಸ್ ಇದೆ ಅಂದ್ರೆ ಪಿನ್ ನಂಬರ್ 3 ಮೇಲೆ zoom ಮಾಡ್ಕೊಂಡು ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ. Zoom and look at the pin diagrams. Please zoom it. Pin number 3 is on the top, pin number 2 is on the bottom. Confuse ಆಗುತ್ತೆ. Okay, so left click ಮಾಡಿ 90 vertical ಕೊಡಿ. Left click ಇದನ್ನ ಸೆಲೆಕ್ಟ್ ಮಾಡಿ ಲೆಫ್ಟ್ ಕ್ಲಿಕ್ ಮಾಡಿ ಸೆಲೆಕ್ಟ್ ಮಾಡಿ ರೈಟ್ ಕ್ಲಿಕ್ ಕೊಟ್ರೆ ಯು ಕ್ಯಾನ್ ಸಿ ಫ್ಲಿಪ್ ವರ್ಟಿಕಲ್. ಫ್ಲಿಪ್ ಅಂದ್ರೆ ರಿವರ್ಸ್ ಆಗುತ್ತೆ. Okay, place this left click 90 degree clockwise. Okay, check. Flip vertical. Okay, give it as flip vertical. Now check. Pin number 2 has come on the top. Pin number 3 has come on the bottom. Okay, so pin number 4 is on the top. Pin number 7 is on the bottom. Hushara ಮಾಡಬೇಕು. This is pin number 7. ಅರ್ಥ ಮಾಡ್ಬೇಕು. This is pin number 7. Okay, ಇಲ್ಲಿ ಕೊಟ್ಟಿರೋದು pin number 7 ಇದು ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ ಇದರಲ್ಲಿ. Okay, ಇದು ಅಂತ ಕೊಟ್ಟಿದ್ದಾನೆ ಬಟ್ ತಪ್ಪಾಗಿದೆ. ತಪ್ಪಂದ್ರೆ ಶಿಫ್ಟ್ ಆಗಿದೆ ಪಿನ್ ಕೊಡಬೇಕಾದ್ರೆ ಅಷ್ಟೇ. Okay, be careful. That is not the pin number 7. This is pin number 7. Okay, this is pin number 7 and this is pin number 4. Okay, this is pin number 2 input. Iga I'll show you. Please zoom it and I'll show you few things here. Okay, if you check out this is VS minus anta kaanatti. Okay, you can see VS minus, right?
Yes, sir.
VS minus ಅಂದ್ರೆ minus VCC ಅಂತ ಅದು minus power supply ಅಂತ. Pin number 4 is minus VCC ಅಂತ. You can see pin number 7, this is VS plus. This pin is VS plus. VS plus ಅಂದ್ರೆ that is plus VCC. ಈ ಪಾಯಿಂಟ್ ನ ಪ್ಲಸ್ ಗೆ ಕೊಡಬೇಕು. Whereas ಈ ಪಾಯಿಂಟ್ ನ ಮೈನಸ್ ಗೆ ಕೊಡಬೇಕು ಅಂತ ಅರ್ಥ ಅದು. This is minus VCC ಅಂತ. Okay, similarly you have two inputs. One is pin number 2 inverting input. That is why it is given as minus here. Okay, pin number 3 non-inverting input. Okay, that is why it is given as plus here. That is why it is given as plus here. Okay, and the output pin is pin number 6. Output pin is pin number 6. Okay, fine. So ನಿಮ್ಮ ಸರ್ಕ್ಯೂಟ್ ನೋಡ್ಕೊಂಡ್ರೆ ಏನೇನ್ ಬೇಕು ನಿಮಗೆ? I need 2 resistors. I need 3 resistors R1, R2 and R. I need 3 resistors R1, R2 and R. Therefore select this resistors value. Come back to this selection. Okay, go for this basic, select this resistor value, green color select ಮಾಡಿ 1, place 1, second, third, place ಮಾಡಿ. You need one capacitor ಅಲ್ಲೇ ಇದೆ. So take one capacitor, place. Okay, you need 2 power supplies. One for minus VCC, the other one for plus VCC. ಎರಡು power supply ತಗೊಂಡೆ. I have taken two power supplies, one for minus VCC, the other one for plus VCC. Okay, and I need ground. Ground ildale ಏನು ಮಾಡಕ್ ಆಗದೇ ಇಲ್ಲ. Therefore, I need one ground. That's all. That's all. Now left click on this R1. Okay, 90-degree clockwise. It will be properly rotated. Okay, so connect this R1 to pin number 6. Connect this R1 to pin number 6. Okay, this to R2. If you look at the circuit, R2 other end goes to ground. R2 other end goes to ground. Similarly, pin number 3. Pin number 3 is a feedback pin. If you look at a circuit, pin number 3 is a feedback pin which comes in between R1 and R2. Which comes in between R1 and R2. Okay, so pin number 2 goes to capacitor waveform here. Okay, the capacitor other end of capacitor comes to ground. Other end of capacitor comes to ground. Okay, na? So this resistor comes to this capacitor, pin number 2. Okay, the other end of this resistor will come to pin number 6. Other end of the resistor comes to pin number 6. Hinge the circuit. Okay, now pin number 4 is Vs minus, hence give it to minus voltage. Minus on the short form. Short line is minus. The plus will come to ground. The plus will come to ground. Okay, so pin number 7 is plus. So pin number 7 is plus. Okay, so minus will come to ground. Minus will come to ground. Okay, so now change the values. We know this is 5K. 5 anta kottu kilo ohm anta ide nodi, kilo ohm hange irli illi. Okay, kilo ohm hange irli. Okay, kodi. Okay, we have selected this C1 as 0.1 microfarad. We have selected this C1 as 0.1 microfarad aayithu idu. Okay, this is 10K. Account calculate R1 equals 1.16 times of R2. Okay, this is 11.6K. Okay, atho hengo kodona tondre illa. Okay, this is 10K. This is 10K. Okay, I have changed all the values. Okay, now you have oscilloscope here. You can see here. Okay, drag towards your right. Drag towards your right. You can see oscilloscope anta kanutte illi. Oscilloscope ಮೇಲೆ left click ಮಾಡಿದ್ರೆ select ಆಗುತ್ತೆ, ಅದು ಬಂದು ಇಲ್ಲಿ ಕೂತ್ಕೊಳ್ಳುತ್ತೆ, ಇಲ್ಲಿ place ಮಾಡಿ. Okay, where you need to see your waveform. ಇದರಲ್ಲಿ you can see, if you zoom, you can see 3 connections here. 4 ಇದೆ, ABDT ಅಂತ ಇದೆ, ABGT ಅಂತ ಇದೆ. I will be not using T. Trigger pin use ಮಾಡ್ತಿಲ್ಲ, only we will be using only 3 pin, A, B and G. G stands for ground, A stands for input, A stands for input, B stands for output. Okay, so first let me connect G ground to ground. Connect G ground to ground. Pin number A, give it to the input. Input on the capacitor kodi. Okay, pin number 2 is my input. B is pin number 6. Pin number 6 is kotail. Okay, now you can see this button here. Topic bunny. See, scroll to the top. You can see this run. You can see this run here. Click madi. Run mel click madi. Run mel click madadaga. You can see at the bottom, it should show numbers ಬರ್ತಾ ಇದೆ, TRAN ಅಂತ ಬರುತ್ತೆ, ಟ್ರಾನ್ಸಾಕ್ಷನ್ ಅಂತ. ಪಕ್ಕದಲ್ಲಿ ಸರ್ಕ್ಯೂಟ್ 2 ಸಿಮ್ಯುಲೇಟಿಂಗ್ ಅಂತ ಬರ್ಬೇಕು ನಿಮಗೆ. ಸಿಮ್ಯುಲೇಟಿಂಗ್ ಅಂತ ಬಂತು ಅಂದ್ರೆ ದಟ್ ಮೀನ್ಸ್ ಇಟ್ ಈಸ್ ಸಿಮ್ಯುಲೇಟಿಂಗ್ ಅಂತ ವರ್ಕ್ ಆಗ್ತಿದೆ ಅಂತ. ಡಬಲ್, ಈಗ ಅದಾದ್ಮೇಲೆ ಡಬಲ್ ಕ್ಲಿಕ್ ಆನ್ ದಿಸ್ CRO. ಡಬಲ್ ಕ್ಲಿಕ್ ಆನ್ ದಿಸ್ CRO. ಡಬಲ್ ಕ್ಲಿಕ್ ಮಾಡಿದ ತಕ್ಷಣ ಯು ವಿಲ್ ಗೆಟ್ ದಿಸ್. ಪಾಸ್ ಮಾಡಿ, ಯು ಚೇಂಜ್ ದ ಸ್ಕೇಲ್. How beautiful it is. Check how beautiful it is. How beautiful it has come. Okay, so I repeat how to do this anta. Okay, so you hope you got with the connections. Once you do the connections, take a CRO. In that CRO, give pin number A to pin number 2. Pin number A na pin number 2 kodi. Pin number B na output pin number 6 ಗೆ ಎಲ್ಲಾರು ಒಂದು ಕಡೆ, ಆ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಎಲ್ಲಾರು ಒಂದು ಕಡೆ ಕೊಡಿ. And G give it to the ground. Okay, G give it to the ground. Okay, now after that you have a button called as run here on the top. So run that. If you see at the bottom, it should show you simulating anta. Okay, double click on this CRO. You'll get this waveform. No other run button pakkadale pause anta barutte. Okay, press on the pause. Okay, waveform stop ಆಗುತ್ತೆ. Waveform stop ಆದಾಗ what is that you need to do? You need to measure what is your T on, what is your T off. ಎರಡು ಒಟ್ಟಿಗೆ ಮೆಜರ್ ಮಾಡಬಹುದು. ಇಲ್ಲಿಂದ ಒಂದು ಫುಲ್ ಸೈಕಲ್. Okay, one on period and one off period. T on and T off. ನಿಮ್ಮ waveform ನೋಡಿತು ಅಂದ್ರೆ you can see that T T on, T off, separate agide. T on plus T off is T. Okay, you can measure your T on, you can measure your T off. Okay, look at this value. 1.1 millisecond ಬರುತ್ತೆ T2 minus T1 ನೋಡಿ ಅಲ್ಲಿ. Look at T2 minus T1. T2 minus T1 is 1.1 millisecond. T2 minus T1 is 1, book ಅಲ್ಲಿ ಬರ್ಕೊಳ್ಳಿ ಅದನ್ನ. T2 minus T1 is 1.1 millisecond. Okay, 1.1 millisecond. F equals 1 by T. T2 minus T1 ಅಂದ್ರೆ ಏನು? It is total time period T. It is total time period T. So T equals 1.1 millisecond. T equals 1.1 millisecond. F equals 1 by T. F equals 1 by T. ಅಂದ್ರೆ 1 by 1.1 millisecond ಬರುತ್ತೆ. 1 by 1.1 millisecond, which is equal to 909 hertz. Okay, ಮಾಡಬೇಕು ಅದನ್ನ book ಅಲ್ಲಿ. Okay, the output ಏನು ಬರಿಬೇಕು ಅದಕ್ಕೆ ಅಂದ್ರೆ output equals T equals 1.1 millisecond. T equals 1.1 millisecond. F equals 1 by T. F equals 1 by T. Therefore, F equals 1 by 1.1 millisecond. F equals 1 by 1.1 millisecond, which is equal to 909 hertz. 909 hertz. ಅದು ಬರಬೇಕು. ಬಟ್ ಕ್ವಶನ್ ಕೊಟ್ಟಿದ್ದ ಎಷ್ಟು ಹರ್ಟ್ಸ್ ಅವನು 1 ಕಿಲೋ ಹರ್ಟ್ಸ್ ಕೊಟ್ಟಿದ್ದ ಅವನು 1 ಕಿಲೋ ಹರ್ಟ್ಸ್ ಕೊಟ್ಟಿದ್ದ. ಬಟ್ ನಮಗೆ ಬರ್ತಿರೋದು ಎಷ್ಟು 909 ಹರ್ಟ್ಸ್. 90 ಹರ್ಟ್ಸ್ ಶಾರ್ಟ್ ಆಗಿದ್ದೀವಿ. ದಟ್ ಅಷ್ಟೇ, ಜಾಸ್ತಿ ಏನು ಶಾರ್ಟ್ ಆಗಿಲ್ಲ. 90 ಹರ್ಟ್ಸ್ ವಿ ಆರ್ ರನ್ನಿಂಗ್ ಶಾರ್ಟ್. Okay, yeah, so that's it. Okay, so look at the manual and you can start writing in your observation book. Okay, thank you. See you in the next class. ಹಂಗೆ ಬರ್ಕೊಳ್ಳಿ ಬೇಕಾದ್ರೆ ಹಂಗೆ ಸ್ಕ್ರೀನ್ ಅಲ್ಲಿ ಹಂಗೆ I'll be sharing. If you want you can write down this ಎರಡು circuit along with the waveform, which very important is T equals 1.1 millisecond. F equals 1 by T. 1 by 1.1 millisecond, which is equal to 909 hertz. That is the final answer which you need to write in the exam also. Okay, once if you copy down all these things you can leave.
Sir,